In miniProject number 23, we created a simple wireless link, and I remember talking about application of such links in RC toy cars. In this miniProject, let's create one such toy car using a bunch of wheels, motors, Arduino, and of course nRF24L01. Let's get started. There are two parts to this miniProject: remote and toy car. Here is how we are going to go about it. First, we'll talk about hardware and software of remote, followed by that of toy car. Remote's hardware consists of three parts: 3.3V Arduino Pro Mini, nRF24L01, and 4 push buttons. Arduino reads status of push buttons and transmits it using nRF24L01 connected on its SPI interface. This circuit schematic shows connection between different parts of remote. Like hardware, remote's software consists of three parts too: variable initialization, setup, and loop. Variable initialization includes specifying nRF24L01's CE and CSN pin connection to Arduino, along with address to be used by RF pipe formed between remote and toy car. Variable initialization also includes pin allocation for buttons. In setup part, we set pin mode of all push buttons to input pull-up. This avoids use of external resistors. Following pin mode is NRF radius initialization. In loop part, we read state of 4 push buttons, form an integer array, and transmit it. This process repeats every 100 milliseconds. By the way, link to GitHub repository containing code and schematic is in the description. My intent behind making these videos is to let my viewers learn and be able to reproduce these miniProjects. Needless to say, I learn a lot during this process. I encourage you to share your feedback about these videos in comments. Now, let's talk about toy car. Its mechanical hardware consists of chassis made out of acrylic sheet and components assembled on it using M3 nut bolts, which includes one universal wheel, 2 plastic wheels, and 2 6V geared DC motors. On electronic side, we have 3.3V Arduino Pro Mini, nRF24L01, and 3.3V regulator on a PCB. To drive motors, I am using L293D motor driver kept on 4 SLs, which adds up to 6V. We covered details on nRF24L01 in miniProject number 23. Let's talk about L293D in this miniProject. It is a quadruple half-edge bridge driver. With proper data inputs, each pair of drivers form a full edge bridge reversible drive suitable for motor applications. Here is functional table and pin diagram of L293D. If enable is set to high, output follows a pin. This is functional block diagram of L293D. We will use arrangement shown on left in this toy car. This circuit diagram shows complete electrical connections of toy car. Like remote's Arduino code, toy car's Arduino code is also divided in three parts: variable initialization, setup, and loop. First part includes NRF radio setup identical to that of remote radio. We also define Arduino pins that connects to L293D motor in this segment. In setup part, first we set 4 pins that connects to L293D as output, followed by startup code for nRF24L01. In loop part, we wait for availability of an integer array of size 4, on whose reception we activate appropriate output pins depending on which button was pressed on remote. That's all the hardware and software needed for this miniProject. Let's take our toy car for a ride.